Good morning, my dear students. Today we will have brief description about register set of Pentium microprocessor. The content of this presentation is we must understand what is a register means, then the rich set of Pentium register, the flag register and other registers supported by the Pentium. What is a register? Register means registers are a type of a computer memory that is built directly into the processor or a CPU. CPU stands for Central Processing Unit and that is used to store and manipulate the data during the execution of instructions. A register may hold an instruction, a storage address or any kind of data, but everything is stored in terms of a bit sequence or individual characters. A register is composed of multiple flip-flops, which are electronic circuits capable of storing a single bit of information, which is represented through binary data, either 0 or 1. By combining multiple flip-flops, registers can store larger binary values such as byte, word, or double word. Example is that uh, any microprocessor, how many bit it is, according to that the register inside it having same length. 8085 is a 8-bit processor, so its register's length is 8 bit, while 8086 is a 16-bit processor, so registers inside the 8086 all are 16-bit registers. 386, 486 and Pentium, that is 80586, are all 32-bit registers. So register length inside these microprocessors are of 32-bit. Registers also contain control logic circuitry which allows it to coordinate the flow of data and instructions within the CPU. Together, flip-flop and control logics work in partnership within the registers. Flip-flop will provide the storage capacity while control logic facilitate the coordination of data transfer, manipulation and synchronization with other components of the CPU. Now we will have the register set of Pentium. Pentium supports three types of registers: general purpose data registers, segment registers and status and control register. Status and control register also called as a program status word or flag register. The Pentium has 10 32-bit and 6 16-bit registers. These registers are grouped as general purpose registers, control registers and segment registers. The general purpose registers are further grouped into data registers, pointer registers and index registers. From the diagram you can see that general purpose registers all are 32-bit, that is from 0 to 31, while segment registers are all are 16-bit only, that is from 0 to 15, and status and control register, that is a E flag register and EIP, both are 32-bit. General purpose registers from Pentium. There are 8 32-bit general purpose registers that hold the operands for logical and arithmetic operations, operands for address calculation and memory pointers. Their names and their role are as it is. See EAX. E stands for extended and AX is an accumulator. Accumulator will always store one operand and after the execution it will store the result. EBX, it stores the pointer to the data that is stored in data segment register. ECX will act as a counter for string manipulation instruction or any loop operations. EDX will store the port addresses in and out instruction. ESI. SI stands for source index. It will act as a pointer to the data when it is pointed by the data segment register. This is a source pointer, source index for string operation. EDI, that is DI stands for destination index register. It is a pointer to the data in the segment pointed by the extra segment register, and this is a destination pointer in the string manipulation instruction. ESP stands for extended stack pointer in the stack segment register. Stack segment. EBP, this is a base pointer to the data on the stack. in the stack segment. Though the registers of Pentium are 32-bit, the lower 16 bits of the general purpose register can be used as AX, BX, CX, DX, BP, SP, SI and DI, as well as they can be used as a 8-bit as per the need of application. They can be used as a 32-bit with having a prefix E that is extended as per your application. And each of the lower 2 bytes of the EAX, EBX, ECX and EDX register can be referenced by the names as AH, BH, CH and DH, that is a high byte, AL, BL, CL, DL, that is a low byte in the real mode. Whenever you switch on the Pentium, it will work in a virtual fast 886 mode where uh, it can address only 1 megabyte of memory. At that time, it can access 8-bit and 16-bit register. The segment registers, there are 6 segment registers that hold 16-bit segment registers. A segment selector is a special pointer that identifies a segment in memory in the segmentation process of a memory management unit. The 6 segment registers are CS, SS, DS, ES, FS and GS. The CS stands for core segment, SS stands for stack segment, DS is a data segment, ES is a extra segment, FS and GS, uh, they all hold the selectors. The E-flag register, Pentium supports a 32-bit E-flag register that contains a group of status flags, control flags and a system flags. This is a diagram of a Pentium E-flag register, and you can see the flags are grouped into 3 categories: status flags, carry flag, parity flag, auxiliary carry flag, zero flag, sign flag, overflow flag. While control flag is a DF, that is a direction flag. System flags are TF, trap flag, IF, interrupt flag, IOPL, IO privilege level, anti-nested flag, that is nested task it is, RF, that is resume flag, VM, virtual 886 mode, AC, alignment check, VIF, virtual interrupt flag, VIP, virtual interrupt pending, ID flag, instruction pointer, and Pentium is having EIP, that is extended instruction pointer, where always IP fetches the next instruction that is to be executed. Remember that the upper 16 bits of the flag register will work in protected mode operation, while lower 16 bits of the flag register will work in a real mode. So this is all about the 16-bit uh, lower 16-bit flag register of a E flag of a Pentium. The flags are divided into 3 groups: control flag, system flag and status flag. The control flags are IF, that is interrupt enable flag, DF direction flag and TF trap flag. The status flags are CF carry flag, PF that is parity flag, AF auxiliary carry flag, ZF zero flag, SF sign flag, OF overflow flag, NT nested task and IOPL input output privilege level. Most of the instructions that require the use of the ALU, it will affect the flags. After execution of any particular instruction into the ALU, it will set or resort the flags bit into the E flag register. And remember that the flag allow ALU instructions to be followed by conditional instructions. This is the meaning of every flag register from the E flag register, their operation and their role. CF stands for a carry flag. If after execution of any instruction MSB results out a carry, then this flag going to set. PF, that is a parity flag. If your result indicates number of ones as a even, then this flag going to set. Auxiliary carry flag. Whenever there is a carry generated from the third bit into the AL register to the fifth bit, then auxiliary carry flag going to set. Zero flag indicates if result equals to 0. Overflow flag indicates that overflow is occurred in the result. Whatever result generated into a particular register, it is not accommodated into that. IF, it is an interrupt flag, enables or disables the interrupt. DF, that is a direction flag. Whenever you are doing the string manipulation instruction, it will act as a pointer. TF, that is a trap flag. If you want to debug any program, you have to set the breakpoints, and after executing every instruction, you can check the contents of a particular register or a memory location. IOPL, priority level of a current task. Every task is having some priority into the Pentium. NT, that is a nested task. If your tasks are nested, this flag going to set. The other registers supported by Pentium are control registers. There are four 32-bit control registers, namely as CR0 to CR3. It is also supported by debug registers. When you want to debug any particular program, you are setting the breakpoints, and these debug registers you can use to check the contents of a memory location or a register after executing every instruction. Floating point registers. To execute the floating point instructions, there are 8 80-bit registers are supported, which are used to execute the floating point instructions. This is all about the rich set of Pentium of a registers. Still, it is a CISC machine, that is complex instruction reduced set. So I think you are understood this, and thank you for listening. Have a nice day.